So hello, math magicians. Today we're going to be writing and graphing using point-slope form, in contradistinction to what we already know. So if we recall, we know what slope-intercept form is. Just to give us some information there, y equals mx plus b, and each one of these is a different thing. M is the slope, tells me how to move, hence the m. And b is my y-intercept, tells me where to begin on the y-axis when I'm graphing it. We also learned about vertical lines and horizontal lines. A vertical line always takes the form that looks like this. X equals some number a. And we know that the slope is undefined. In other words, there is no slope, or we can call it undefined. And I'll abbreviate here. The other one is a horizontal line where y is some number b. And this b is the same as the previous b over here, where it does mean the y-intercept. And this slope here is always 0. In other words, m equals 0. So we've already seen that, and today we're going to look at a new thing called point-slope form. And we can derive it. Derive means to create it from another place. So we're going to derive it using the slope formula. But by way of introduction first, please take a moment to look up here. Paul and Seth know that one point is on a line 4, 2, and the slope of that line is negative 5. Each student wrote a different equation relating x and y. So let's walk through step by step just to see what Paul and Seth here did. So it looks like Paul took slope-intercept form and substituted everything he knew. The point was 4, 2, so he substituted those in for x and for y. And he took the slope negative 5, substituted in. Seth, on the other hand, started from a different place. Instead of slope-intercept form, looks like he started with slope, with the y2 minus y1 over x2 minus x1. And he substituted the 4 and the 2. 4 went down here, and the 2 went up here. The negative 5 went there, but then he didn't, he kind of replaced that second point. There is no second point, so he generalized it to an x and a y. So let's see further what Paul did here. As you can see, Paul combined these two here to become negative 20, and just to show that work there, he added 20 to both sides, so that dropped out, and we got 22. So b is 22, so he substituted that value into there, and he substituted the original slope into there, y equals mx plus b. Seth, on the other hand, did something that looks a little bit more complicated. What he did after he substituted things in is that he got rid of the x minus 4 by multiplying by x minus 4 on both sides. This looks like a little bit complicated right now, but it is possible to do. And he ended up with this situation. So the question now you need to consider is, number one, do the equations represent the same line? So now you're going to think about why. And next, you're going to generate a table of values using this Paul's and then using Seth's. I suggest using a few, say for example 0, 1, and 2. And try 0, 1, and 2 for this one here and see what you get. I'll let you check the answers here for at least these ones there. Of course, consider that and make a conclusion. In plugging in these same values and getting out the same values, what can we say about these two equations? All right, so scroll down with me here, and we're going to look at slope formula and the new form. The new form, of course, is called point-slope form, and we'll unpack that in just a second. We're going to actually take Seth's method here and try to move things around. So let's first off look at y2 minus y1, what slope is, and x2 minus x1. Okay, first thing. If I were to generalize one of the points to be all points, so x and y there, and so notice I just dropped that little 2. And then we have the other one, which now is x1 right there. So we have that. Now, if we take and do exactly what Paul did before and multiply both sides by the bottom, by the whole thing that we see, Notice that when we multiply, they essentially reduce to 1. So I'm going to multiply this side also by x minus x1. And so let me see what I get. I bring down this m, and then I bring down this x minus x1. And on the right side, we're left with y minus y1. It turns out when I flippity-flop these two, then that is the form that we are now going to be calling point-slope form. Why? Because it tells me instantly a slope and a point. So the slope and a point, x minus x1. So let's just clarify here. The m, of course, as usual, m stands for slope. And my y1 and my x1 together is a point on the line. A point on the line. If we were to graph it, another way of saying is that it's the point that satisfies this equation. Okay, so use it and see where we get. So notice on the next page our instructions say this: write an equation in point-slope form. So don't forget, whenever we see that phrase point-slope form, we should always think, and it's even better to write down, the y minus y1 equals m times x minus x1, like so. So over here on the example 1, a line has a slope of 3 and passes through point 2, 1. So a couple things I can note here is that my 3 is my slope, so that's my m. 2 is my x1, and 1 is my y1. So when I am thinking about my point-slope form, I get this, such that m times x minus x1, like so. Now all I have to do is substitute exactly what I see. The m goes here, the y1 goes here, x1 goes here, and then we simplify if need be. So y minus a 1 equals my m, which is 3, times an x minus a 2. And now I pause to see if there's anything to reduce. There's no double negatives here. This doesn't reduce, and I do not have to send it in. Why don't I have to distribute? Because it asks me to write it in point-slope form. So this is point-slope form, because I see parentheses and I see something with the y. That won't always be the case, but that's generally the case. So I'm done. We stop there. This is point-slope form. Now please take a moment to try A and B. And then, so pause now and then come back and check your answer. And there we have the two results. Follow the next video to see the next parts here.